All right, let's take a look at lesson 5.5. We are expanding and condensing logarithms. So to do this, we have three rules. Okay, first is product rule. Product rule is when we see multiplication in a logarithm, m times n. You're going to separate that into two logs with the same base, separated by a plus sign. So the multiplication separates into addition. Quotient rule. Division will separate into subtraction. And then the power rule, if I have, after my base answer, I have a little exponent here, not after the equal sign, but before the equal sign, it is going to move to the front of my logarithm. And then I can also go backwards. So subtraction would go to division, addition to multiplication, and a number in front would become an exponent. So let's take a look at this with some examples. The other thing we want to keep in mind here with some of these is that rule with a radical, which we went over in 5.4, where a radical is a fractional exponent. So I have, say, for example, 3 cube root of b squared as an exponent that is going to be b to the 2/3. And I like to use the acronym TBO, where top inside, bottom outside. So the top of the fraction inside the radical, bottom of the fraction outside the radical. So that's TBO, T-I-B-O. Okay, so let's look at example 1. First thing we have in example 1 is you have an x to the 4th cube root of y. So you have two terms, and this is separated by nothing. So we assume there's multiplication right there. So we're going to take the multiplication, separate that to addition using the product rule. So we're going to say log, and we're going to carry the base. So that's the base b, x to the 4th. And then we're going to make this plus. Then we're going to write log b again. And then we're going to write this cube root of y. The next thing we are going to do is we are going to apply, okay, this TBO rule here, where we're going to make the radical into a fractional exponent. So I'm not going to do anything to this log b x to the 4th. So I'm just going to bring it down. Okay, but this I'm going to make log b, and this is going to become y to the top of the fraction comes from inside the radical. There's nothing inside, so it's an assumed 1. Bottom of the fraction comes from outside the radical, so that's a 3. So we have y to the 1/3. Then I am going to apply the power rule. So I'm going to take these exponents and I'm going to bring them to the front of my logarithms. So this is going to become 4 log b x, and then this will be plus 1/3 log b y. And now I am fully expanded once I cannot expand any further. Let's take a look at another example here. So the first thing that I have here is I have some division going on, and I also have some multiplication down here. So I'm going to start with the quotient rule, where I'm going to go log 5, and I'm going to have square root of x. The division is going to turn into subtraction. And I'm going to have log 5, 25, y cubed. Okay, then I'm going to apply the product rule right here between the 25 and the y cubed. So I'm going to take that and I'm going to make that into plus. So this is going to be log 5, 25 plus log 5, y cubed. Now you can put this in parentheses if you want, but it is not necessary to do so. Okay, then bring down your log 5, square root of x. Then you want to make this into a fractional exponent. So the inside of here, that is an x to the 1st. So that'll go on the top. Bottom, outside, there's nothing there. That's an assumed 2. So square root is just 1/2 power here. All right, so if we bring down the rest of the problem, here is what we're looking at. And then we're going to take our exponents and we're going to bring them to the front of our logarithm. So this is going to become 1/2 log 5x minus log 5, 25. And then this 3 is going to come to the front. So plus 3 log 5y. Now, you may think you're done here, but even though we're expanding and we want it to be as big as possible, we do still want to simplify when we can. So if you look at that log 525 there's our screen, sorry about that. This can actually be simplified. So think about your rules of exponents. Log 525, your base would be 5. Your answer would be 25. This is what you were missing. So 5 squared is 25. So log 525 actually equals 2. So you can simplify that and just make that into a 2. So our final answer here is going to be 1/2 log 5x minus 2 plus 3 log 5y. Okay, then example 3, we are condensing, which means we're going backwards. You know you are done condensing until you have one logarithm. So condense into a single logarithm. So now we're going backwards. So this is addition. We will make this multiplication. So this will become log 25 times 4. And then simplify from there. 25 times 4 is 100. Log 100. Go ahead and check what that is. That's 10 to what power is 100? Or you can put that in here. And there you should get 2. So that is your single logarithm, 2. Example 4, you have log 7x plus 6 minus log x. So you're going to take care of this minus sign and make it into division. So you're going to have log 7x plus 6 in the numerator, x in the denominator. Because the 6 does not have its own logarithm, this doesn't mean that I am distributing. Okay, this is just the log here. I do not need to make this into another log. Okay, this is already expanded. I am condensing now. So this is all I would need to do for example 4. All right, example 5, you have numbers in front of your logarithm. So you're going to start with those numbers and you're going to apply the product rule. So this is going to go to the x as an exponent. So it's going to become natural log x squared. This is going to come to the x plus 5 as an exponent. So that's going to become natural log x plus 5 to the 1/3. Then you want to take this and apply this into our rule to make this into a radical. So that means I'm going to go natural log radical x plus 5. The top of the fraction goes inside the radical, so there's a 1 there. I don't need to write the 1. The bottom of the fraction goes outside the radical, so I have a cube root there. And then finally, single logarithm, I'm going to take this plus sign, make that multiplication. So I'm going to have just one natural log, and I'm going to have x squared times cube root x plus 5. You do not need to type in that times symbol. I just like to, or I might even put a parentheses here, just because I don't want that to look like a 23. Okay, so now we have some practice problems. So go ahead and pause the video, work on the practice problems, and then press play when you are ready. So this first one here is a little bit complicated. Okay, we are going to condense this logarithm. So let's take a look at what we have here. You have addition and subtraction. So start with the addition. That means multiplication. So you're going to go ahead and you're going to make this natural log. This is going to be x over x minus 10 times x plus 10 over x. Then you have the subtraction, which also just means division. So you can just go ahead right here and make that x squared minus 100. Now Take this natural log, move it to the middle. Well, now you've got a lot of simplifying to do. So let's first take a look at the numerator. These x's, they can cancel out because you have one on the bottom, one on the top. Okay, so now your numerator looks like this, x plus 10 over x minus 10. And then you've got this, x squared minus 100, which you should know here factors x plus 10, x minus 10. So I have this in my numerator, this in my denominator, which means I'm going to divide by, I'm going to write it out like this so it's easier, x plus 10, x minus 10, which means I keep the first fraction, change this to multiplication, flip this. So I get an x plus 10, x minus 10 on the bottom, and a 1 on the top. And now I can multiply. When I do my multiplication, I have 1x plus 10 on the top and 1 on the bottom. That cancels. And then I have 2x minus 10s in the bottom, which do not cancel. So what I'm left with here is a 1 over x minus 10, x minus 10. Put your natural log right in front of that. You can leave it like that if you want. If you want to multiply it out, that is fine as well. That's going to be 1 over x squared minus 20x plus 100. And that is up to you. Oops. Okay, so let's take a look at our next example. So we have natural log e to the x plus, or not to the x plus 5, so ex plus 5 here. Okay, so well, there's really not anything to do here with this natural log and this e. These are just going to cancel each other out because there was nothing after. I feel like this might be copied down wrong. Let me pause this and look at my notes because I don't want to come across the same mistake we had in 5.3 where something didn't print out correctly. Okay, so I took a look at it, and the only thing about this is that this should be an exponent, so it's just ln e to the x plus 5, in which case this isn't actually an expansion problem. This is just ln and e cancel each other out, and the answer here is x plus 5. So that's all we've got to do there. All right, let's take a look at number 3. So we've got expansion here. In the top of my fraction, I have 2 terms. I've got the x and the x plus 3. So we're going to start there. So we're going to go log. So I'm starting in the top left. So I've got log x. Then you have times x plus 3. So we're going to make that plus log x plus 3. And then I'm going to put the x plus 3 in parentheses because it's more than one term. Then I have divided by. So I'm going to take the division sign, make it minus. So you start in the top left, go left to right, and then go down. And then you've got log. And let's see here. That is going to be x plus 5 to the 8th. And then from there, you're going to take the 8, apply the power rule, and that looks like that's about it. So you've got a log x plus log x plus 3 minus 8 log x plus 5. And now we are fully expanded. All right, last thing in 5.5 is the change of base formula. So when I have a logarithm, okay, with a base, when I put it into an exponential form, and I can't solve it easily, I can put it in my calculator. So if you have the TI-84, you can just put it in your calculator just like this. But if not, you're going to do the answer part over the base. So it's going to be log 2506 divided by log 7. So just keep in mind, this is on the bottom because it's down here, so that stays on the bottom when you're dividing. That helps you. So you get log 2506 divided by log 7, and there you get 4.022. Okay, so remember this is the base 7 answer would be 2506. So to check that, you would do 7 to the power of your answer. So second answer, you should get 2506. So same thing here for example 2. Change this to logarithmic form. So you have log, b would be your base, so that would be 5. Your answer would be 134, and then that's going to give you your x. So to use the change of base formula, do log 134 divided by log 5. So let's see, log 134, close the parentheses, careful on that because you're only doing log of 134, divided by log 5, you get 3.043. Okay, check it, put it back in the original problem, 5 to that power. So 5 to the second answer, 134. Okay, then you have 10 to what power? Same thing, so you would do log. Your base would be 10. Your answer, 8,000, equals your exponent. You don't need the 10 here in your logarithm. You can just do log of 8,000. And that would give you 3.903. And you can go ahead and check that. 10 to the power here, so 10 to the second answer, you get 8,000. So number 4, there's a complicated way to do it. I'm just going to go ahead and make this the easy way for it. What to the 6th power is 2534? Just take the 6th root. Okay, so do the opposite root here. Okay, so take the 6th root of 2534. So 6, math, number 5, 2, 5, 3, 4. And that should give you 3.692. And then go ahead and check that. Take that and go to the 6. And you get 2534. And that is it for 5.5.